Problem number 24 asks us just to simplify and state the excluded values. And I notice problem number 24 happens to be a complex fraction, which means a fraction within a fraction, or fractions within a fraction. There are two ways to approach this. I will show you both on here, and then you can choose the one that makes the most sense to you. The first thing that I'm going to look for, regardless of the method that I'm choosing, is common denominators. So I'm going to start with a common denominator. So we'll call this one method 1. And you don't have to label which way you're doing it. I'm just so I can differentiate them on this page. So method 1, I would be finding my least common denominator for the entire problem. Meaning I'm looking at this denominator, this denominator, this denominator, and this denominator, and trying to find something that's in common. And remember, when we find something that's in common means it has all parts included. Well, I know I need a number 3 because there's a 3 there. I know I need an x, and I know I need a 1 because what's written under this 2 is 2 over 1, but 1 times 3 is 3, so I don't need an additional 1, nor would it change the problem any. And I don't need an additional x because this x is already taken care of. So my least common denominator is 3x. Method 1 does this. If we take and multiply this entire fraction by the least common denominator, what that looks like is I would multiply this expression here by 3x or 3x over 1, and this expression by 3x or 3x over 1. Now, let me write it out in steps what this looks like. We would have 3 times 3x over x plus 2 times 3x. All of this would be over 9 times 3x over x plus 4 over 3 times 3x. Okay, it looks messy. But what I'm going to do now, let's move that up and over just a bit. What I'm going to do now is I am going to simplify, and I'm going to cancel like terms. Notice that I have an x and an x, those go away. I have an x and an x, those go away. I have a 3 and a 3, and those go away. So now I'm going to reduce this. This numerator I'm left with 3 times 3, which gives me 9. I'll go ahead and write what I'm left with. 3 times 3 plus 2 times 3x all over, and I'm left in here 9 times 3 plus 4 times x, and that's what I'm left with. So I'm left with 9 plus 6x over 27 plus 4x. What I would look for is to see if I could cancel anything. I cannot. So this would be my simplified expression using method 1. And we'll go back and talk about excluded values or domain restrictions here in just a second. If we were to do method 2, the other method that we have is to find or to create one fraction in the numerator and create one fraction in the denominator and then copy dot flop. So using method 2, the first thing I'm going to look at is this top fraction. And what I'm going to do is find a least common denominator for this top fraction, only the top fraction, which means looking at x and 1, my least common denominator would be 1x. So I'm going to multiply each of these fractions by what's missing. So I had 3 over x. I don't need to multiply that by anything. Its denominator's already x. And this one I have 2 over 1, but I would need to multiply it by x over x. And so what I get here in this expression, let's see if I can move this again. What I get here in this expression is I get, and remember this is just the numerator, so we get 3 over x plus 2x over x, which means we get 3 plus 2x over x. So this is the numerator's one fraction. That's the whole point. One fraction for the numerator. Now I'm going to repeat that same process for the denominator. So I'm going to find a least common denominator for the denominator. And to do that, I see that my least common denominator here would be an x and a 3. I need both. So we'll call this 3x. And so I'm going to multiply each, whoops, let's not change the problem. I'm going to multiply each fraction by what's missing from the common denominator. Well, for this first fraction, I'm missing the 3. And in the second fraction, why do I keep trying to rewrite the top? I am missing an x. So I'm going to multiply this by x over x. And when we do that, I get 9 times 3 is 27 over 3x plus 4x over 3x. You might be tempted right here to say, oh, I see they have common factors. But if you start removing the common factors they have now, what's going to happen is you're going to end up back where you started. So don't do that. Combine like terms first. So we get 27 plus 4x over 3x. And this is my denominator. So now what I'm going to do with my new numerator, which is 3 plus 2x over x, and my new denominator, which is 27 plus 4x over 3x, is I am now going to copy dot flop. I'm going to multiply by the reciprocal of that second fraction. So 3 plus 2x over x times 3x over 27 plus 4x. And now what I'm going to do is multiply straight across unless I see any common factors. And I do. I see a common factor that can cancel. And so the common factor that I see cancels is this x and this x. They're attached by multiplication. They can cancel. And so what I'm left with, once those go away, is 3 times 3 plus 2x over 27 plus 4x. If I multiply the numerator through, we would get 9 plus 6x equals, over 27 plus 4x. Here's what I want you to notice. I didn't want to move them separately. Here's what you should notice. Why can I not group these? Group. Okay, here's what I want you to notice about the two methods. Let's see if I can zoom in. If we go and look at these two methods, do you notice that these are the same? So it doesn't matter what method you choose, whatever one makes the most sense to you. Let's talk excluded values or domain restrictions because we haven't done that yet. So if we talk about our excluded values, remember excluded values or domain restrictions are things that make our denominator 0. So if I go back to the original problem and look at my denominators, this denominator's x. Well, what makes x 0? 0. So x can't be 0. This denominator's 1. Well, 1 can never be 0, so that doesn't make sense. And we already talked about what happens with x. That's because that's part of the common denominator. And 3 can never be 0 either. So my excluded values, regardless of which way I do it, is that x cannot be 0.